In this module, we will discuss the overall benefits cold working provides. Cold working can be an inline weld bead conditioning process or a secondary manufacturing process to obtain total cross-sectional reduction. This process further enhances quality, corrosion performance, and dimensional flexibility. Here's Ed Blessman with some expert insight on cold working.
Hello, I'm Ed Blessman, Technical Development Manager at Plymouth Tube Company. Cold-drawn tubes are seen in applications which require tubular products to go beyond standard commercial requirements for consistent tolerances and mechanical properties, such as motor and pump shafts, pneumatic cylinders, and aircraft hydraulic tubing. If you're considering cold working, it's important to know how the effects of cold working can impact the product's size and microstructure. Cold working can be isolated to just the weld or to the entire cross-section of the tube. When performed, weld bead reduction provides improved corrosion resistance of the weld by creating more uniform microstructure and properties throughout the tube. The cold drawing process can be used to achieve tighter dimensional tolerances, non-standard sizes, elevated mechanical properties, and improved surface finishes on tubes. Certain ASTM specifications may reference cold working of the welds, but they have no specific requirements, and some have no cold work requirement at all. Remember, the absence of cold working can lead to dimensional issues at the welds.
The term cold working refers to the low ambient temperature of the material when the cold working process is being performed, typically at room temperature. In the cold working process, a high amount of mechanical force is applied to reshape the material. This process is accomplished below the recrystallization temperature. The actual process of cold working, while being important as defined in the corrosion resistance segment, has very broad meanings and interpretations. The goal of the cold working process in general is to reshape the metal to a new size or thickness, making it harder, stronger, and more uniform in the process. This can improve the strength and corrosion resistance of a material and decrease the ductility. Cold working is an important manufacturing process relative to the corrosion performance and close dimensional tolerances that can be accomplished. But not all ASTM specifications require cold working or weld bead finishing. The purpose of cold working is to homogenize the weld microstructure, ensuring that mechanical properties, dimensions, and corrosion resistance are consistent throughout the tube's perimeter. Proper weld bead working is comparable to tube reduction or drawing of hollow. Cold working can be grouped into two categories: inline bead working and cold drawing. Typically, inline methods are used on tubing for applications such as condensers, evaporators, semiconductors, and wine. Roll forging is where the top and bottom rolls of material are fixed longitudinally. Then the top roll oscillates vertically, hammering or forging the weld. An ID mandrel, usually made of carbide, is centered in the tube under the forge roll, providing support for the tube and the mandrel. Inline bead reduction is the process where cold working of the weld bead is performed directly on the forming and welding mill. It's performed immediately after welding operations to ensure that the weld is maintained in a controlled position. The cold working is accomplished by applying pressure with roll tooling on the OD surface, reinforcing the ID with a hardened mandrel and supporting the opposite side of the tube with another backup roll. Cold drawing is a cold forming method that accomplishes the full cross-sectional reduction. Originally developed for the seamless process, cold drawing provides the greatest amount of effective cold work and flexibility of any tube manufacturing methods. The tube is mechanically pulled through a die, which reduces the OD size and wall thickness, while the ID is supported with either a fixed plug or a full-length bar. As the tube is pulled through the die, the tube is resized. Some advantages of cold drawing are dimensional, tight tolerances. The cold drawn process is capable of providing approximately half of the traditional roll-formed OD tolerance. These tolerances can be significantly tighter than seamless cold drawn tolerances, since the welded hollow is very concentric. When this process is performed, the weld can be very difficult to distinguish. The cold drawing operation provides an ironing effect on both the OD and ID surfaces. This smooths the surface, thus reducing the roughness commonly measured in RA. Typical surface finish of a cold drawn material is in the 20 to 30 micro-inch RA or better. Size capabilities. Create sizes that aren't attainable otherwise. Very heavy or very light wall welded tube can be made by starting with a larger diameter tube and drawing to the final size. This allows the use of thicker or thinner walls than possible with roll forming and welding. Higher strength. Most stainless steels are not heat treatable for higher strength. For many applications, such as mechanical or aircraft applications, stainless steel tubing is cold drawn to raise the tensile and yield strength. In some cases, the yield strength may be 3 times the annealed value. Cold reduction also eliminates the need for OD polishing. Material that has a fully finished weld has a lower potential for fatigue failures due to poor weld profile. The cold work process also provides a clean uniform weld thickness, reducing the ID crevice that could be a failure point, lowering the probability of failure at the weld. The clean uniform surface provided through cold working also improves the reliability of the NDE inspections with the lower background noise. The quality cold working provides relative to enhanced tolerance capabilities. Consistent microstructure and improved product performance are all things that should be considered when evaluating cold working in your application and specifications. These corrosion enhancements can often deliver significant value compared to or in addition to other methods of corrosion control.